myself Naveen Kumar Saini. In the course of wireless and mobile communication, today we are going to discuss about the topic that is fading. So this is a course content where we will discuss about the fading and the type of the fading, that is large scale fading and the small scale fading. So first of all, we must know what is the fading. Fading is nothing but this is the signal attenuation. When we transmit the signal from the transmitter and it receive at the receiver side, so this signal will travel multiple path. So because of traveling the multiple path, their signal attenuation occurs. It means the signal strength is reduced. So in that way, if we define that parameter, that is fading, so the time variation of received signal power due to change in the transmission media or the path is known as the fading. So in this diagram we can see that when we have multiple copies of the signal and it travels through the multiple path. So what is the multiple path? So one path is the line of sight path from the transmitter to the receiver, and another paths are some of the path will be due to the scattering of that signal. So we can see it here that when we have transmitted signal and it is transmitted through the multiple path, like multiple obstacles. So one path is from there, second path is this one, and so on. So these obstacles are maybe the cluster of the buildings, maybe the cluster of the mountains, or maybe there may be different more obstacles may be there between the transmission and the medium. So there are various other measurements to find the fading. That is maybe if any signal is transmitted with some different angle of transmission and it receive at a different angle of reception. So in that way also the fading may occur, because at the transmission side and the receiver side the signal must be of the same synchronization must be there. So the other major impact of fading, that is due to the atmospheric condition such as the rainfall and the lightning, geographical positions, time and radio frequency. So these are the some of the impact which occur through the fading when we transmit the signal from the transmitter side. So due to which this signal deterioration occurs at the receiver side. So now it depends that if the signal is adding at the receiver constructively or the destructively. If it is adding at the receiver constructively, then the signal strength may be increased, but if it is added at the receiver side destructively, in that case the signal strength may be reduced. So there are various phenomena to analyze the fading concept in the wireless communication system. So this fading, as we have just discussed about the fading, major component of the fading, but we have another factors also. We classify those factors in that way. First one is the fixed scenario. So this in the fixed scenario fading, this depends on the atmospheric condition. So this atmospheric condition can be of the rainfall and the lightning. So this raindrops is basically one of the major component which will be used to scatter the signal. So if any signal is reflected or diffracted due to this rainfall, so in that way the signal strength will be reduced. Another scenario is the mobile scenario. In the mobile scenario, this fading can be experienced based on the obstacles over the path. So this obstacle over the path or with respect to the time. So as the signal strength is changing with respect to the time, so these time varying phenomena in the mobile scenario occurs and it impact the fading concept. So these obstacles create the complex transmission effects to the transmitted signals. So in this way the fixed scenario and the mobile scenario both are responsible for the fading. So fading is nothing but this is the deterioration of the signal strength when it is transmitted by the transmitter. So when we classify the fading into these two parts, first one is the large scale fading, second one is the small scale fading. So this large scale fading is again the two types. So this large scale fading can occur because of the path loss and the shadowing, and the small scale fading it can occur due to the multi-path delay spread and the Doppler effect. So this classification is very important to understand about the fading, because this fading these results occur because of the for the long distance communication and for the short distance communication. So in the when we measure the large scale fading, so the for measuring this large scale fading, two components we have to take care. First one is the path loss of the signal, path loss. Second is the shadowing of shadowing effect on the signal. Second, multi-path delay spread. When we talk about the small scale fading, again it is divided into two parts. First one is the flat fading and second one is the frequency selective fading. So in the same way, these two classification occur because we are taking the parameter of multi-path delay spread. So when we take the another parameter of the fading, that is in the categorization of small scale fading. So this Doppler spread again is divided in two parts. First one is the fast fading and the slow fading. So this classification is based on the different type of environment and the different type of obstacles which occur between the transmitter and the receiver. Okay, so by this, which one is more dangerous in fact say in the wireless communication, that is the small scale fading. So this small scale fading categorization of the flat fading and the frequency selective fading can be in the both way, that the flat fading can be with the fast fading and this flat fading can be with the slow fading. Similarly, in the case of this frequency selective fading can be the frequency selective fast fading and the frequency selective slow fading. Okay. So now the fading in the lens mobile systems. So in that, as we have also discussed about this fading concept, in which the transmitter transmits the signal to the receiver. So when it is received at the signal, due to the fading, the signal overlapping may occur and the deterioration of the signal will also occur. So this deterioration of the signal is nothing but is called the ISI. ISI is the small intersymbol interference. So these two types of fading, that is large scale fading, this is due to the obstacle for radio propagation over long distance, and the small scale fading, this occur the fluctuations in the signal strength and phase over the short distance and the small duration of the time. So this is very dangerous in the wireless communication system, that is small scale fading. So in this classification, the large scale fading, as we said, the two components, that is the path loss and the shadowing. So in the path loss, how we calculate this? Parameter. So we use the average attenuation, which is exponential proportional to the distance, and based on that we take the logarithmic scale to simplify the fading. And when we combine this fading of the path loss with the shadowing, in the shadowing what happens? This shadowing effect occurs because of the large buildings or the mountains, and this type of large scale fading is called the shadowing. So this occurs due to the diffraction of the signals through the or scattered from the different buildings or the mountains. So when we combine these two effects in the path loss and in the free space and the large in the shadowing, so we call it as the large scale fading. So this large scale fading is mainly due to two effects, as we have mentioned, the path loss and the shadowing. So we have different mitigation techniques to remove the ISI in the large scale fadings. So in that this case can occur by maybe through the power control, maybe using the antenna placement, repeaters and the site diversity. So these concepts can be utilized for removing or mitigating the intersymbol interference, and based on that we can also reduce the large scale fading effect. Okay, so ISI is one of the major factors in the wireless communication system which we have to mitigate it. In the case of small scale fading, as we have mentioned, the effects on the small scale fading, that is due to the random frequency modulation due to varying Doppler shifts on the different multipath signals. So this Doppler shifts occur because of the relative motion of the receiver as compared to the transmitter. So in that way, we can see we have the base station. So this base station transmits the signal, and this is the receiver in the moving vehicle, in which there are two type of components are there. Obviously, first one is the line of sight component, which is from the transmitter to the receiver, and second component will be the non line of sight component. So in this non line of sight component occur due to the different obstacles between the transmitter and the receivers. It means when the signal is transmitted from the base station, it will travel through the multiple path to reach at the receiver. So in that way, there will be a different angle of arrivals at the receiver side. So this due to the moving vehicle, this Doppler effect is occurred. So in that way, this Doppler shift can caused by the angle of arrival relative to the motion of the receiver. So this in this way, because this is following the different multipath signal, so this multipath signal will occur due to the different obstacles. So in that way, this multipath will receive at the receiver at the different angles of arrivals. So this is again the one of the major factor for the small scale fading. Time dispersion, that is caused by the multipath propagation delays. This is due to nearby objects. So as we can transmit the signal, and when we transmit it at one time instant of the time, so it is not possible, most probably, if there is an obstacle, then it doesn't mean that the transmitted signal will reach at the receiver side in a synchronized manner. So it may happen the delayed version of the signals can be reached at the receiver side. So in this way, the time dispersion can occur by the multipath propagation. Okay, so this delay occur at the receiving side. So this is again the part of the small scale fading. That is movement of the surrounding objects. This is a major factor for the Doppler shift. So if we see the delay spread and the intersymbol interference, so delay spread effect is, as I have mentioned, about due to the small scale fading, and this can cause the ISI intersymbol interference. So with this diagram, we can see if this is our the line of sight signal, that is a direct signal, and this signal is the reflected and delayed versions of the signal. So when we combine these two signals, so the resultant signal will be looks like this one. So there is a superimposition of the direct LOS and the non-LOS signals. So when you combine these two signals at the receiver side, then the combined signal will be looks like this one. So this is a distorted signal at the receiver side. So because of this distortion, because of this type of distortion, it is very tough to detect the proper signal. Okay, so because of that, the ISI or intersymbol can occur. So here there are some measuring axis delay parameters. So in this way, the some finite delay between the time at which the antenna receives the first copy of the signal on the shortest path and that which is received at the last copy of the same signal on the longest path. So this is the maximum delay which can occur between the first transmitted symbol and the last received symbol. So based on that, we have the two parameters. First one is the maximum delayed time spread. So it is the total time interval during which reflections with the significant energy will arrive. Root mean square delay spread, it is the standard deviation or the root mean square value of the delay of reflections weighted proportional to the energy in the reflected waves. So this is a weighted signal which can be calculated with the help of the standard deviation to find the root mean square delay spread. So here the representation of signal is there, that at one time instant of tau naught, that this signal is looks like this. So when we have another time instant of time, that is a tau 1, so this is the shifted version of the previous one. Similarly, tau 2 is the third time instant, so this is again the shifted version of the previous symbols. So when we combine these three signals, so what is the representation of this? This is representing that the signal are transmitted at the maybe tau naught at time, but it is receiving at different time instants. Maybe the t is equal to 0 at the time signal were transmitted, but it is receiving at the receiver at the tau naught time period, and second one will receive at the tau 1 time period, and third one will receive at the tau 2 time period. So when we combine these three signals at the receiver side, then in that case the signal will looks like this one. These are staircase signals are looking like this. So in this way the signal must be achieved like this one. But if we are not getting that signal, so in this way this portion is nothing but this is called the ISI or intersymbol interference. So the same signal must be received like this one. If we are getting the multiple copies of the signal, in that case when we combine it at the receiver, then the interference can occur. So we have the various methods to reduce the ISI, intersymbol interference. First one of the type is the equalizer. So at the receiver side we use a equalizer to reduce the or mitigate the ISI, or can reject the ISI at the receiver side. So how we can do that? First method is the orthogonal frequency division multiplexing. So by this method we can use to reduce the ISI or intersymbol interference. So these are one of the very major method or using the ISI reduction. So it is possible to remove the interference also difference between the symbols using the filter. So in that second method we have the Nyquist zero ISI criteria to reduce the ISI or intersymbol interference. So another method is for reducing the ISI or to mitigate the ISI, to control the ISI, is by the transmission rate. So if we can control the transmission rate, so based on that we can mitigate the ISI or intersymbol interference. So there are a few of the definitions like the coherence bandwidth, resolvable paths. So let's see first, that is the coherence bandwidth. In the coherence bandwidth, for a reliable communication without using the adaptive equalizer or the another anti-multipath techniques, so the transmitted data rate may be much smaller than the inverse of the RMS delay spread. So this is the condition for coherence bandwidth, and the signal bandwidth must be less than the coherence bandwidth. So in that way the signal which is received at the receiver, it will be reduce the ISI or the intersymbol interference. So this is the condition. If the system follow this condition, so based on that the intersymbol interference can be reduced, and that bandwidth is called the coherence bandwidth. Second one is the resolvable path. So what is the phenomena into this category? In that wideband signal with the symbol duration Ts. Okay, so in this we use the DS CDMA system. So in this DS CDMA system, direct sequence CDMA. So in direct sequence what we use the PN sequences at which we use the PN sequence at the transmitter side and at the receiver side. So both the PN sequences must be known to the transmitter and the receiver side, so that we can resolve the different paths and for the detection at the receiver side. So the condition for that resolvable path is NP is equal to, that is the round off of T delay and the T chip plus 1. So T delay is the delayed version of this period of the signal which is received at the receiver, but this T chip is nothing but the one time period of the PN sequence. if we have the 10 bits in the PN sequence, so in that case T chip will be what? T chip will be the one time period of the 1 bit of the PN sequence. So in that, what we have taken the round of figure of this NP value. So we will take the largest value of the largest value of this expression, T delay upon T chip plus 1, whatever the maximum largest value will be there. So we have to choose that value so that we can decide what a number of paths we can use for transmission of the signal or the multipath phenomena. Okay. Next, that is your Doppler shift. Doppler shift, as I have mentioned, that this Doppler shift interference or this Doppler shift occurs due to the relative motion of transmitter and the receivers. If we have the change of the frequencies, in that case with a different angle of arrivals, so based on that we calculate the Doppler shift. So we can see if we have a base station here in this example and we have the moving object, so in that case when the base station transmits the signal, so this signal will pass through the different obstacles. So that obstacle may be the building, or there may be the sum of the direct path, and there may be the some another tall buildings, so which will be maybe the reason when we have the receiver which is moving in nature. So multiple signals can come from the base station 1 and the base station 2. So we can see that when this receiver is moving the base station 2, so in that case due to the base station 1 the received signal frequency will be less as compared to the when it is moving towards the second base station, so the received signal frequency will be high. So it means that this base station must receive the signal from the base station 2. So that is why the another very major effect occur in the case of the moving vehicles, when moving vehicle which can be responsible for the ISI or inter-symbol interference at the receiver side. Now, so when we classify this small scale fading, so it is based on the two parameters. First one is the multipath time delay spread, and second one is the due to the Doppler spread. So these conditions, as I have just mentioned in the previous slides, that this classification of multipath time delay, based on this multipath time delay spread, we have the flat fading and the frequency selective fading. So in the case of flat fading, this bandwidth signal, which is the original bandwidth signal, that must be less than the bandwidth of the channel signal, or you can say this is the bandwidth of your that is the coherence bandwidth. That must be signal bandwidth must be lesser than the coherence bandwidth. So in this way we can reduce the ISI and the flat fading can occur. So it means that all the components of frequency will be on the same amplitude. Second is the delay spread is less than the symbol period. So these two cases are for the flat fading, and opposite of that, when we have the bandwidth of the signal, that is the BC, is greater than the bandwidth of the Doppler's coherence bandwidth or the bandwidth of the channel. So in both the cases the frequency selective fading can occur. Second case of frequency selective fading is delay spread. When it is greater than the symbol period, then the frequency selective fading occurs. Now based on the relative motion of the receiver, so this fading occur in two ways. First one is the fast fading, second one is the slow fading. So in the fast fading, high Doppler spread, this is the characteristics for the fast fading. High Doppler spread, coherence time must be less than the symbol period, coherence channel variations which is faster than the baseband signal variations. Okay, so these three are the condition for the fast fading. And when we talk about the slow fading, the conditions or the feature for that one is low Doppler spread, coherence time is greater than the symbol period, channel variations which is smaller than the baseband signal variations. So if we look in this with this categorization of the fading, then we find that this flat fading and the slow fading, these two combinations are comparable and the compatible for the system to reduce the ISI. So these two conditions we want to achieve, or the goal we want to achieve when we are doing the wireless communication system. So in this, what happened in the flat fading case? So this flat fading case occurs when the amplitude of the received signal changes with time. Okay. So the example for this flat fading is the Rayleigh distribution. Second case, this flat fading occurs when the symbol period of the transmitted signal is much larger than the delay spread of the channel. So in this case, the bandwidth of the applied signal is very narrow. Okay. So as we are very much aware that what we have the wide band of frequencies. So our goal is to reduce that wide band of frequency into smaller chunks. So if we can divide this wide band of bandwidth into the smaller chunks, then these chunks are called the subcarriers, or these subcarriers are very narrow in bandwidth. So it will be responsible for the flat fading, right? So this may also be cause the deep fade. So increasing the transmit power to combat this situation. Okay. So one method I have mentioned that if we have the wide band of frequency, we can divide it into the smaller band of frequencies. Second way of when it is not in deep fade condition, so we can use some transmit power control mechanism to reduce the signal to be into the deep fade. So based on that we can use it. So here we have the signal, that is the transmitted signal, we have the received signal, and here H, this H is nothing but the fading. This H is the modeling of the fading, that is H t comma tau. So t is the time instance through which we are transmitting a signal, and this tau is the delay which is provided or achieved when the transmitted signal is transmitted or follow the multiple path. So in this way, this symbol period is the Ts and the channel symbol period is the tau. So in this way, this is the spread of the signal. It means this signal is your in the deep fade. Okay. So these things occur because of these two conditions. First one is the Bs is very much less than Bc. That is the this Bs is what? This Bs is the baseband signal bandwidth, and Bc is this is nothing but the coherence bandwidth. So it means the signal bandwidth must be very much less than the coherence bandwidth, or the symbol period is greater than the delay spread. So based on these two conditions, we say our signal is into the flat fading condition, right? If we talk about the frequency selective fading, so this is just opposite of the flat fading. So in that, this frequency selective fading occurs through the multipath delay spread, which is greater than the symbol period. So these symbols face the time dispersions, and the channel which induces the ISI inter-symbol interference. This ISI is really very dangerous for wireless communication system. So this frequency selective fading is the one of the reason for that. So in this, the bandwidth of the signal ST is wider as compared to the channel impulse response, right? So in this way, we can see transmitted signal, this is the channel, and this is the received wider band of the transmitted signal. These two are the conditions as I have just mentioned in the previous slide, that Bs is greater than Bc, Ts is less than tau t, delay spread. Okay. Fast fading, which is based on the Doppler shift, and this occurs due to the range of change of the channel characteristics, which is larger than the rate of channel of the transmitted signal. So if I have also mentioned about the coherence time, which is channel is smaller than the symbol period of the transmitted signal. So these two conditions occurs for the Doppler spread for the fast fading, BS is less than BD and TS is greater than TC. Slow fading, opposite of the fast fading case, that BS is greater than BD and the TS is greater than TC. Or you can say the signal bandwidth is greater than the Doppler spread shift, and this symbol period is less than the coherence bandwidth or you can say coherence time of the signal. Okay, so these all are the comparisons between the small scale fading and the large scale fading. So which one is very rapid in the nature? That is the small scale fading, and it is large scale fading is very slow and it causes by the multipath. In the case of small scale fading and large scale fading, the path loss and the shadowing. There are various parameters based on the that the different effects are there into the small scale fading and the large scale fading. So I hope you understood about the fading and what are different types of fading which we have discussed. So these all are the references. We can go through that report and the Open Dalal book through which we have taken the slides and we prepared that. So all of you can go through it. Thank you very much.